So we're going to go on to the next section now, which is namespaces, right? So far we've just been worrying about the file system, but we haven't been worrying about other things, right? So if I have two chrooted environments next to each other, right, they can actually still see each other's processes, right? So if I am inside of one chrooted environment and I say PS, right, which is how you can actually see that right here, this shows me that I have this running and this running, right? These are the two processes running at any given time, right? So if I do this within each chrooted environment, assuming that they both had all the necessary libraries and all that kind of stuff, they could see each other's processes, right? So again, if I'm company A and company B is also running in there, company A can just say, you know what, kill their web server, right? Because they can see each other's processes, right? Seems like it would be problematic, right? So that's what namespaces are. Namespaces are these, the idea of these various different facets of Linux that we can limit each one of these particular, these jailed processes to, right? Or these container environments. So I can say, hey, you can only see your own processes, and you get your own process IDs, and you get your own networking layer, and you can't mess with anyone else's. You can only mess with your own environment. So I'm going to do something. I'm going to say tail-f my new root or secret.txt, right? So what this is going to do, this is going to start a long running process right now, right? So it's just running this tail-f secret.txt. What this does is, like, if anything got added to this, it would start showing that. But I'm just doing this to show you what happens if something is just a long running process. I'm going to open another shell here, and I'm going to connect to that same Docker environment. So I'm going to say docker exec-it docker-host bash. This is going to open another shell in the same container. Right, so now 1 and 2 here are both connected to the same container. Does that make sense? So if I say PS here, you can see that it has the same things running. Oh, right, because I have to do PS aux. So you can see here it has tail-f, right? So in order to see that, I had to ask for more things, right? That's what the AUX does. So you can see here, I had this PID 103, which is the tail that's running in the other process. So if I say docker kill, or not docker, sorry, kill 103, now if I go back over here, notice that this stopped, right? It says terminated, right? That's because from the other connected shell, I just said kill that process, right? So this is the issue that we want to prevent, right? We want to prevent people from doing this to each other. And so that's what namespaces allow us to do, right? So if I have these two different processes, I can say, hey, this one, you can't see what's happening over here, and vice versa. And we're going to do that with a environment called, with namespaces, right? That's what we're going to do. Oh, and we're going to use a command called unshare. All right, so I'm here in my same container, and I have my new root here. I'm actually going to create a better root, and I'm going to show you how to do this. So the first thing I want you to do is say apt-get update. This is going to go and update like your list of packages that you can download. This should take, you can see here, it's going to download 11 megabytes. And that did that. And we're going to say apt-get install dbootstrap, and I want to put dbootstrap. That TST always messes me up. -y. And again, this will download a couple of tools so that we can use this tool called dbootstrap. Instead of having to go and hand copy all of these various different, it's going to download a few things, all these various different tools, like one by one, and looking at their libs to get the right things, I'm going to show you how to use a tool called dbootstrap that's just going to set up an entirely new, totally valid, change rootable environment. So now that you've downloaded dbootstrap, we're going to say dbootstrap --variant equals min base, which is going to download just the the most minimal amount of tools that you need possible. You can tell it what kind of Ubuntu or Debian to download for you. I'm going to say Bionic, because that's what we've been using, 18.04. But you could totally say Stretch here, and it would work. Stretch is Debian, not Ubuntu. Ubuntu is based on Debian, if you're unaware of that. Okay, and then I'm going to put that into /better root. And again, just so you know, this is going to do about 150 megabytes of worth of download, so just be aware of that. If that's a thing for you, then you can just watch, and you'll get most of this without having to do it yourself. Okay, so I'm going to run that. This is going to take probably about, depending on how fast your internet is, up to 3 to 5 minutes maybe. Hopefully, since we have pretty fast internet here, this should only take like a minute. But what this is actually going to go do for you is it's going to get a bare minimum set of like a file system that you need to run a Debian-based Ubuntu. So dbootstrap is actually Debian Bootstrap. So when they're building containers for Debian and for Ubuntu, they actually use this tool to bootstrap a brand new environment. And it's done with the idea that you can chroot directly into it. So they actually use this to like build Ubuntu and stuff like that. So we're kind of co-opting it for our own nefarious purposes. So now this is finished debootstrapping, right? So if I go into better root, you can see here it's got basically everything that I saw up here, right? It's got a temp of var, user, sys, serve, run, sbin, all that kind of stuff, right? So now I can say change root dot, right, to be inside of this better root, bash. And you can see here, everything works now much better because it has all of the various different tools. So I look inside of bin, you can see I have quite a bit more tools that I can use, right? In fact, it's kind of even hard to tell the difference of, am I inside of the change root environment or am I inside the normal environment? It's hard to tell. Okay. So now I can get out of this, and I'm back into the normal one. And now we're going to do something called unshare, right? So I'm going to say unshare, and here I have to tell it everything to unshare from this new process I'm creating, right? So I'm saying unshare the network, unshare the file system, unshare the UTS, which is like the process managing system, right? So I'm going to say unshare dash dash mount, so unshare all the mounts, the UTS, which is the processes, IPC, which I cannot remember what is it at the time, the network, the PIDs, which is the process IDs, fork, which again, I don't remember, users, like all the users parts, the map, root, user. Okay, and then you're going to tell it what to run with that unshared environment. So I'm going to say run change root, and I want to do it in /better-root, and I want you to run bash, right? So this chroot part, that should look familiar to you. That's exactly what we were doing before. But now we're just adding unshare in front of it to unshare all these namespaces, right? So now I'm in this, right? And if I look at ps-aux, oh, it's going to say, hey, you need to mount the process system first. So go ahead and run these commands with me as well inside of your chrooted environment. We're going to say mount -t proc none /proc, which is for processes, and then we're going to do it again for sysfs none sys, and mount -t tempfs none temp. All right, so now that we've done that, we can say ps-aux, and we can see here that it cannot see outside of itself, right? You look here that this bash, right, the bash that we're in at the moment is PID1, which is what we would expect, right? But that's the one that's running inside of the unshared chrooted environment. It's not the one running outside of it. In fact, if we come back to our other shell that we've connected to this, if we say ps-aux, we can see the unshare, we can see the bash, we can even see the all that kind of stuff running, because we can, from the host, we can see inside of the child, but the child cannot see outside of itself, right? So let's say if I said, again, did the tail fs or tails -f root secret.txt, right? So now this is running again. If I go back to the other environment and I say psaux, still can't see it, right? And if I'd say tail f, let's just say touch text or text.txt, and I said tail dash f text.txt, and I come here, we'll stop this, and I say psaux again. You can see this one can see the tail because it's the parent process looking into the unshared environment. And you can also see this bash here, which is the one that's running down inside of the unshared environment. Its PID is actually like 7536, right? So it actually it maps these PIDs to the host environment. Now I'm showing you just processes, right? We actually unshared the network, we unshared a bunch of other stuff from this environment. So it is truly containerized in terms of the namespaces that it can access, right? So if I wanted this to be able to connect to the network, I would actually have to like create a separate network inside of here and connect that to the host network, which then would connect to the broader network, right? I'm not going to show you how to do it, mostly because I'm not really sure how to do it. We could figure it out, but it would take a while. And this is kind of to drive home the point that you can unshare these namespace capabilities, right? So change routing is like unsharing a file system, right? Namespace is about unsharing capabilities from these particular processes or controlling the capabilities that flow into these processes, right? Does that make sense?
Brian, why do we need to run the mount commands? What did that do after we unshared?
So the mount one is so that the environment can know, like, it can access like the process system and the system file system. It doesn't do that automatically by itself, right? Whereas like when you start up a Ubuntu process, it does do that stuff for you. So you just have to like mount in all these various different capabilities to the operating system. You're just telling us like, this is where you find this stuff.
Kind of like additional library, so to speak. If you need this, go there.
Yeah. You got a question?
So the exit command that terminates the process, does that also get rid of the previously created container at all?
So
when you exit on your terminal?
Yeah, so if I went back, let's see, to this one, and I said exit here, this would terminate this unshared environment and would go back to wherever it was, right? So in this case, because I'm just doing it directly from the host, it would send me back to the host. But like if you're connecting to my computer and I want to like limit you, I'll just have you, if you exit it, you would just exit out of the connection entirely.
What would be the house cleaning command to see how many containers I have? And also if I want to manage them, delete some, how do you usually go to navigate through them?
So typically you're not going to be creating containers by hand like this, right? This is a wildly wasteful process. It's more an academic exercise than something you would ever do. Docker has a bunch of stuff that just does that for you, right? So there's a thing that says Docker PS, and it'll show you all of your running containers. Does that answer your question? Cool. Let's go back to just one more fun exercise. So I'm tailing this text thing as well, right? And if I do Docker, or not Docker PS, psaux again, to see all my running processes, you can see here that I can actually grab this PID right here, and I can totally say kill 7555, right? Now if I go back over here, inside of the unshared environment, it's been terminated, right? So the host can still control everything that's happening in the child process, but the child process can't see out of it, which is kind of fun. And I could totally just terminate the entire session. In fact, let's do that as well, right? Again, here, if I do Docker PS, psaux, you can see this is PID1, but if I come back over here and I say, I don't know why I keep wanting to do that, Docker psaux. If I come here and I grab 7356 and I say kill 7356, you'll notice if we come back here, it's done. It killed the entire process. You can actually just kill the entire container.